everybody, this is Mrs. Hatfield, and today we're going to learn about how to create a graph and when you should use certain graphs. Just a reminder, this set of videos you must write out all of the notes, and also know that during the notes each slide will add to the previous slide. So you will only have to add the new items to your notes. Please do not recopy everything from each single slide. Alright, this is just a review for you about independent and dependent variables. Remember that in an experiment, the variable that you change or that you are testing is the independent variable. And the variable that you are measuring is the dependent variable. For an example, we are going to grow bean plants over the next few weeks. So what are you testing? You are going to actually test the beans to see which one would grow more. And the measuring thing would be how tall the bean plants get. So that would be the independent variable. What would your control be? Your control would be that all the beans are put in the same kind of dirt or in the same baggie hanging on the window, or on the same kind of baggies hanging on the window. Your control would also be the amount of food that you're feeding the bean plants as they grow. Okay, so let's get to graphing. First, we're going to talk about the different kinds of graphs there are and when you would use each one. Okay, so how do you know what kind of graph that you're supposed to make? Well, it depends on the kind of data that you're collecting. In this particular graph, there is a comparison between the different kinds of pets that people own: a rabbit, a dog, a cat, and a goldfish, and a hamster. So they kind of surveyed a group of people, and they saw that from this graph that most people had cats in their house. So to compare what kind of pets are most popular, you would use a bar graph so you could show which one had the greatest amount. So if you're comparing items when you are testing them, like which one would be better to use or which thing happened the most often, then you would use a bar graph. Our second type of graph is called a line graph. A line graph is when you are measuring something over an amount of time. For example, this is what the temperature was for a whole week. On the first day, the temperature was 10 degrees. On the second day, it got a little bit warmer, and then it kept getting warmer, and then it went down, and then it went back up. So your line graph might be straight, like in a slanted line, but it could be up and down. It all depends on what it is that you're trying to find out. If you're trying to measure if the speed goes up when you do something, then you would probably want to use a line graph, not a bar graph. You would also use a line graph if you were going to check how tall a plant grew every single day. That way you could show that over time the plant actually did increase in how tall it got. Okay. Finally, our last kind of graph would be the pie graph. A pie graph would show you things that you wanted to compare if you wanted to show the percentage of something. So in this example, you can see what kind of food that they ate yesterday. So they measured probably how much food they ate at each meal, and then they gave it a percent. So if they ate 3 meals, 10 meals, 40% of the time, or 4 of the meals would have had meat in them, 4 out of 10 meals. Or yes. And they ate ice cream 29% of the time. Boy, would I like to have ice cream 29% of the time. That's an awful lot. They didn't eat very much bread or very much vegetables. So this was an easy way to see what a family ate or a person ate in a certain day. So this is also used for a short period of time, not over like an entire year. It could be over an entire year if you wanted to do that. I didn't like that, so I'm going to cut this out and I'm going to start over. Okay, you would use a pie graph when you wanted to compare the percentage of things. So you would measure certain things for a period of time, or even in one day, or even in 5 minutes, and you would count like how many things happened in 5 minutes, and then you could compare. I hate that one too. All right. Okay, so you would use a pie graph when you wanted to compare things by using a percentage. So it's easy for people to see what happened more of the time than the other times. It doesn't necessarily mean that you have to measure like seconds or minutes. It's just comparing things to each other, very similar to a bar graph, but instead of using like a number like 12 people had cats, you would show that in a percentage. So you would have to actually do some math to figure out what percent would go in each one of the pie pieces. Okay, so now we're going to talk about how do we write a graph or make a graph. First of all, you have to start with a data table. Whenever you are doing an experiment, you have to collect numbers. Remember, we talked about this. You have to measure something. So you have to collect that in a chart before you can actually make it into a graph. So you need a data table, and you need to know your variables. Remember, the thing that you are changing is the independent variable, or the thing that you are testing. And then the thing that you are actually going to measure would be the dependent variable. So in this particular data table, someone is timing something and then measuring how far it goes. So maybe they're trying to say the longer it takes to do something, the farther you can go. So whenever you make a data table, you need to make sure that you include the units. So they measured time in seconds. They could have been hours or days or weeks. So make sure that you include the units in your data table, and you also include the units here in the dependent variable. They measured distance. So did you use meters, centimeters? Remember, we don't use inches, no feet or yards. Everything is metric. So make sure you're using metric units, okay? And you might have more squares than this right here. It all depends on how many tests that you are going to do. Make sure that when you draw a table, you use a ruler and that everything is neat and straight. Okay, you can also draw a data table sideways. You're still collecting the exact same information, but when you draw it sideways like this, the independent variable always goes on top and the dependent variable goes on the bottom. And notice this is the same thing. They're asking for the units for each thing that they are recording. Okay, and they drew it with the straight line with the ruler, and they put them in this particular order. So make sure that you draw a data table in your notes that looks both up and down and a sideways one just like this. Okay? All right, so next. Then we are going to start setting up our graph. We are going to use something called the tails system. So when you guys do a lab, I will always make sure to remind you to use your tails. So make sure that you remember this. This is the part of the notes that's going to keep adding up. So make sure that you draw these on your notes, but just add what is added on each one of the slides, okay? So you can draw these little squares on your paper, but if you just want to draw an L shape like this, that would be fine. Okay, so let's get started. The first thing you need to worry about is the letter the letter Y, because that's the axis. I know there's no Y in tails, right? The Y-axis is the one that goes up and down. And the dependent variable, the thing that you are measuring, always goes on the Y-axis. Okay, the X-axis, which is the horizontal line on the bottom, that's where the independent variable goes, the thing that you are testing. This is the same for every single kind of bar graph or line graph that you will make. The independent variable goes on the bottom and the dependent variable goes on the side. Okay, tails. Okay, T is for title. Your graph has got to have a title. And your title cannot just be measuring. Okay, I know that you're measuring. So what exactly are you measuring? You're measuring the length of the floor. So your title should be length of the floor in meters or something like that. Please do not make your titles really generic. You should also try to make them kind of short because you usually won't have very much space. Okay, so in this particular case, we're going to make a graph about the teachers, all of the teachers' favorite singer. Okay, so we have our title on the top. Next, we're going to do the axes. Again, the axes are these lines right here, the up and down one and the cross one. The x-axis is for your independent variable, and the y-axis is for your dependent variable. Okay, so the next letter that we're going to worry about is the S for scale. This is sometimes kind of difficult to understand, but we're going to work on it. Okay, so you have to pick a scale, and the scale is the distance between the numbers on each one of the little lines that make up the squares of the graph. You have to decide what your scale is going to be. It says, choose a scale that lets you make the graph as large as possible for your paper and your data. So if you have a huge sheet of paper, I don't want a teeny tiny little graph. I want one that'll use up almost the whole sheet of paper. Okay, so this is how you are going to actually determine what your scale is going to be. You have to look at your data table, and then you need to find your biggest number on the data table, which would be 22, and your lowest number on the data table, which is 2. Now your data table may not be organized just like this one. It might be in all different orders, and that's fine. It just depends on how you collect your information. But remember that you need to know the biggest number on your table, and you need to know the smallest number on your table. So when you make the scale for your graph, you need to know that your scale has to start lower than the smallest number and go higher than your biggest number. So since your smallest number is 2, you probably would want to start your graph at 0. And then your next highest number would probably be 24, because it looks like it's kind of going by 2s here. So you just have to pick a number higher than your biggest number. Okay, next. The next letter is I for intervals. So you have to determine the interval. The interval is the space between the numbers. So if your graph is going to start at 0 at the bottom, and then it's going to go up to, say, 24 at the top, you have to figure out how much space is between 0 and 24 and what number you want to go up by. Okay, so right here they're saying that the best interval would be to go up by 5s. You can go up by 1s, you could go up by 2s, you can go up by 5s or 10s. It just depends on your scale. I mean, if you have your biggest number was 1,000 and your smallest number was 2, you wouldn't want to go by 5s because you wouldn't have enough room on your paper for that graph. Your interval would probably have to be hundreds or 500s even. So you really just need to pay attention on how much spaces you have between your numbers. For example, we have from 2 to 22. So if our next number was only 10, we could go up by 10s, or we could even, go up. We could go up by 1s, but again, we probably wouldn't have room on our graph. So we're going to pick 5s. Okay, again, the amount of space between one number and the next one on the data or on the graph is the interval. The interval is just as important as the scale. Choose an interval that lets you make the graph large as possible for your paper or your data. Title, axis, interval, and scale. Okay, you can notice over here how we talked about on the graph, we had to start with a number lower than our first number, which was 0, and we have to go higher than our biggest number. Our biggest number was 22, so we decided to use 25 here. And why 25? Because our interval is 5s, so our number has to be at the next 5. So we went 0, 5, 10, 15, 20, 25. Okay. Then we can put our title of our graph because we knew what we were going to measure. Okay, and then we can plot our points. We had a 22, right? And a 22 isn't 20, but it's not quite 25. So we made the bar graph go part way between the 20 and 25. And the same thing with this one and this one here and this one down here. They were not quite at the number 5, but not quite at 0. So we had to graph them in between. So this is our title. These are our axes. This is the interval, the 5s. The next thing that we're going to talk about is labels. And we talked about scale. Scale was the distance between the smallest number on our data table and the largest number on our data table. Okay, so next is labels. You need to label all of your axes, the sides of your graph. Okay, you have to have a title, and both of your axes have to be labeled. You have to say what it is that you're actually measuring or testing. So you can see on here, each one of these bars represents a different singer. So we're going to go ahead and write the names of the singers. But we're not quite done yet, because even though we put the singers' names here, we also want to give all of these things a category. So what are all these things? These are singers, right? So we're going to go ahead and put those on the graph as well. We need to label them. Give the bars a general label. What do these words down here mean? They're singers, so we're going to give them a label. We also need to do the same thing on this side. Even though we have our interval labeled right here, we still need to give this right here a name. What do those numbers mean? This is the number of teachers. Now, if, let's just say we were measuring seconds or something, or the distance. So if we put on here distance, we still need to put in parentheses meters or centimeters, whatever unit of measure that we are using. Okay, so there we go. We have our title, we have our axis, these ones and these ones. We have our interval, which is the space between each line on the graph. And we have a scale, our distance between our smallest number on our data table and our largest number on our data table. And we have our labels. We labeled both what it is we were testing or measuring, and then we gave the categories a broad name right there, and over here on this side as well. Okay? All right, here's another review. When to use a bar graph. Bar graphs show data that are not continuous. What does that mean? Remember, data is just numbers or information. Okay, and continuous means that they don't go on and on and on, that you measure it one time and you're done. Okay? It allows us to compare data that are alike, or if they have a frequency means how many times something is done, or categories like singers or colors or shapes. It also allows us to make generalizations about the data. What does that mean? That means that when we look at it, we can pretty much say, oh, everybody's favorite animal is the cat. And it helps us to see easily the differences in the data that we collected, the information, the numbers. Okay, line graphs. Line graphs are for continuous data, data that changes over time, like every single day for a month, or every single day for a week, or every minute of every hour. And it's useful to show trends over time. That leaves us to the riddle of the day. A line graph shows change over time. So, what is the easiest way to double your money? Ha, you put it in front of a mirror. Ha, ha, ha. So there you go. Now you know all about a graph and how to make one and how to label one. So go ahead and work on the worksheets that you have to do for class. Thanks and have a great day.